So, welcome to PHEX 2019, hosted by HVP, which is an important year for them. It's their 40th year anniversary. Hands up, anyone that's been reading it that long? I think I'm about 2 years short. My father actually started reading it 40 years ago when it came out. So I'm here today to host my podcast, which is coming soon, called Betatalk. I'm known on social media, particularly Twitter, as Betatalk, and one of the things I want to do, which is going to build upon what I'm seeing on social media, is support the engineers and plumbers that are in this industry. The engineers and plumbers in this industry have a very, very tough job. A lot of onus is put on the engineer and plumber. In Europe, it's a little bit different. I think the consumer and customer base values their engineers a little bit more, and I'm going to try and hopefully get that back in this country. So I'm going to be travelling around the country, speaking to engineers, listening to their stories, listening to their tales, their tips, listening to what they consider good practice, and supporting them, because one of the things I have studied extensively in my time as a college lecturer is how people learn. And one of the best ways we learn is what we call peer learning. So people in the same industry chatting away with each other tend to learn a lot more when they're talking about their topics. And that's what I'm seeing on social media, and that's what I want to kind of build upon when I go around meeting all these engineers all over the UK and chatting to them on my podcast. I will also be going to meet with manufacturers who I think are doing some really, really good stuff and trying to push our industry forward. So I'd like to introduce you to my guests. I've got Derek and Rob from Imi Hydraulics.
Morning.
Imi Hydraulics are very well known to me. They do some great products. They do some de-aeration devices, expansion vessels, but something I'm particularly interested about is their thermostatic radiator valve, which we'll talk about in a minute. And I'm also joined by John from Testo.
Morning.
And we're going to be talking about their instruments, specifically the thermal imaging camera that they do, because I think that could be something that could help our industry drive good practice. We have a very, very thin slice, a thin element in this industry of engineers who are doing things so cheap, they're undercutting everyone else. So the engineer out there who wants to do this good stuff, they're learning about all this stuff and want to do good practices, they're having to compete with just that thin slice that wants to do things not so good. I think if we bring thermal imaging into the industry, so obviously, as you know, a new boiler install would have to have a clean of some sort. I think if a customer sees before and after images of them radiators being cleaned, I think they're going to get used to that, and actually then that may drive things going forward a little bit better to the point where engineers are then able to charge the prices that they really should be allowed to charge. John, so you work for Testo.
Correct.
And you do a few other things apart from your thermal imaging camera. I believe you're actually in the Innovation Centre right at the other end of PHEX Show, is that right?
That's right. Just a bit of background. Testo, as a manufacturer, have been going for just over 60 years. Across a wide range of industries. The heating and plumbing sector is just one of the industries that we support with tested equipment. The thermal imaging is actually a fairly new product in the Testo brand. When we say new, it's been around still for about 15 years or so. And it's one of those technologies that's really come from the top down. If you look at the sectors for things like preventative maintenance in industry, looking at thermal analysis on buildings for poor insulation and insulation qualities, it's always been seen as a very, very high-end type product. But what we've seen over the last few years across the board is thermal imaging becoming available at a lower and lower market price. And really what we've been trying to do in the last few years is say to particularly the heating and plumbing trade is, look guys, there's a really clever technology here that's now reaching a price point that's actually viable for you to use. And the real benefit from thermal imaging is a picture speaks 1,000 words. If you go in to do something like a power flush, or you're looking for pipe work that's buried under the floor, yes, you can say to the homeowner, look, fill the radiator, here's the hot zones, here's the cold, you can see where it's blocked. If you can actually give them a picture of that, it brings the whole thing to real life for them, why they need to have that power flush, why they maybe need to have a new radiator, why you can find the pipework that nobody else can find that's got a leak. So as a non-invasive technology, but a very, very easy to use and a very sort of person-friendly technology from the customer's viewpoint, it's probably unrivaled, I think.
Yeah, I mean, speaking on behalf of some of the engineers I know that are using your technology, their customers have been so excited, is probably the word, because they get a little package of the before images of their radiators before the power flush and the install, and then they get the after images, and they've got a better idea that the job's been properly done. It is possible, as we all know, to go and clean a system and it hasn't actually been cleaned very efficiently at all, which obviously is very detrimental to the boilers. Rob, I go around the country, speak at the low carbon homes events, and one of the things I speak about is your thermostatic radiator valve. Can you tell us briefly why I speak about your particular valve?
Yeah, so, excuse me, our thermostatic radiator valve's the Eclipse valve. The whole idea with this is it's got self-balancing technology. So one of the things we look at as a company with systems, we deal with all of the bits in between really. We don't sell boilers, we don't sell pumps, we don't sell radiators. We do kind of all the little bits in between that are going to make them all work harmoniously together. And one of the biggest things when we're looking at that is the balancing of a system. So traditionally, everything's done on a heat balance, and 90% of heat balances are done with your self-calibrated hands. It's warm, it's cold, you know, every radiator's getting hot, and if every radiator's hot, there must be a balance, which in reality isn't true. There is some modicum of balance, but you can't tell, is it too much heat, is it not enough heat? You just know there's hot water getting there. So the idea with this Eclipse valve is there's a self-balancing cartridge inside it, so you can literally, there's 15 settings on the top, and with the use of our application, we can tell you which setting you need to set the valve to, depending on a room size, a radiator size, or a radiator output. And you can get a fixed setting and say, like, as an example, set it to setting 5. And when that's set to setting 5, there's an auto flow cartridge inside it that will move up and down based on pressure. So the higher the pressure is, the more that will close off, or the lower the pressure, the more it'll open up. So that means it's going to self-balance physically on there yourself. So rather than having to run around and be regulating lock shields, you do it all on the TRV. And it's literally a case of just working out a setting. And if you've got, as an example, 10 rooms in your house, and every room magically has the same heat requirement, same size radiator, every single one would be set to the same. So it'd all be to setting 5.
So it solves a big problem, because obviously when I started out, my dad and I would be running around the house, checking radiators with our hands to see that they're all coming on roughly about the same time. We then sort of went to differential clip-on thermometers. You can go one better than that, which you probably should do, is when you need to be taking ambient temperature as well to properly hydronically balance the system. Yeah. But even then, when TRVs are shutting down in other areas, we can get overflow and underflow situations where the system then becomes unbalanced. Yeah. And as we all know, balancing the systems is actually quite an art. So you've actually got a product that actually takes all the onus of us running around with measuring equipment, and once you've done, it's
you don't even need water in the system to balance it. So you can effectively, some of the things we've done with some of our larger customers is we've taught the more experienced engineers how to set the valves, and they're able to just literally write on the box, living room, they'll preset a valve in the box for the living room, and then they'll go and get their apprentice to go and fit the valve, and they can just turn the system on, and everything comes up as one. So it's not coming up, you're not getting a hot toilet and then a cold living room and waiting for everything to heat up. It literally, so the whole idea is getting that energy efficiency there in your boilers and keeping your return temperatures lower as well.
And we're talking quite high energy efficiencies, aren't we? I think IMI did a recent test, and we're talking about 30%.
Yeah, so something in the region of one of the guys we work quite closely with did a retrofit on his house, and all he's done is changed his TRVs to the Eclipse Tech, balanced them all up on a heat loss based on a heat loss calculation, and then range rated as a boiler accordingly. And I think he was reporting something like 24% savings on his overall gas bill. So that's his complete gas bill. That's not just heating, that's gas in total. So
balancing valves, obviously anyone that's in the commercial sector knows about balancing valves. But as far as I'm aware, this is the only technology for domestic radiators, is that right?
Yeah, it's the only in the domestic size body. This is actually a commercial body because we've got the cutaway, but we're the only ones that do it in the small domestic compression-led body.
Because there's obviously lots of, we're all familiar with the different brands that will manufacture thermostatic radiator valves, but if a technology like this exists where the system becomes hydraulically balanced, it just makes complete sense as we're sort of pushing forward this drive for efficiency. Derek, you're part of the same group, Imi Hydraulics. Now, your expertise is in expansion vessels, I believe.
Water quality. Recently, we've seen in the commercial world, water quality has become a major issue. To reduce carbon emissions, we need to get the water quality going back to the boilers and the chillers at the correct temperatures to reduce the amount of energy they're using. To do so, you use things like an air separator, a dirt separator, and expansion vessels. These items are critical and they're now moving across to the domestic market. And we're seeing in domestic, some of the new boilers, a dirt separator might be incorporated. But the majority of these boilers in domestic dwellings, they're not, and they need to be retrofitted. In today's days, you have your boiler service, the engineer will recommend that you install a dirt separator. So we've got there with dirt separators, and perhaps 10 years ago, the majority of new boilers fitted will have a dirt separator fitted on them. But what we are now looking at is the air quality. And the air quality, by removing microbubbles from your domestic heating systems, you are allowing the return temperature to go back at the design temperature of the boiler or the system. So if you have a condensing boiler, it will condense correctly. There's no point in having a condensing boiler which is 95% efficient if it's not commissioned correctly. And part of the reason why they're not commissioned correctly is because the air is not being removed and you're actually warming up air. Air uses a lot of energy and therefore we're wasting a lot of carbon, especially with our footprint. We're trying to reduce carbon footprint in the UK, and as a consequence of that, we're now really looking into the domestic boiler market and how we can do so. A microbubble air separator removes microbubbles. In most domestic dwellings, we have an automatic air vent at the highest point of the system. That will remove surface air. Surface air is on top of the water. Normally, when the system is drained down, there is air in the pipework, and as you fill the system with water, that air gets trapped at the top, an automatic air vent will expel that air. Microbubbles are a little bit smaller, and they exist in the water, and as you heat that water up, the microbubbles circulate around the heating system. They get trapped in the valves, they get trapped in the radiators, they get trapped in the underfloor heating. Consequent of that, you have pockets of air that you're trying to heat with using your gas or electric source. What a microbubble air separator does, it traps those bubbles to make a big bubble by forcing them through a device which is in the unit that forces one big bubble up to the top. There's a float valve in there, and that float valve then drops down, allows the microbubble air to be expelled from the top of the automatic air vent, and then it seals itself again. So it's a bit different to your standard automatic air vent. So an automatic air vent will remove surface air, but not microbubbles. So removing the two, the dirt separator, which is generally always on the return side, on the return because it goes through your underfloor heating, it goes through your radiators, all your heat emitters, and then before it gets back to the boiler, all the dirt is trapped. And good practice is to have one which has got a magnet on there to trap magnetite. That magnet is removed by the service engineer when servicing the boiler. The magnetite falls to the bottom and it's flushed out, and then the magnet is reinserted and the process starts again. The advantage of that is that when you remove magnetite, that gets in the motors, that gets in the valves. Eventually it will cause premature failure of things like your valves, things like your motors and your control valves, which are expensive components to replace. The other product I'll talk briefly about is expansion. I think the majority of domestic boiler systems that have been installed now are sealed systems. We've done away with the feed and expansion tanks, which used to be in the loft, which caused a lot of oxygen to get in the system. Somebody climbs to the loft and pushes the ball valve down to fill it with water, and we're now sealing the systems with an expansion vessel. Majority of combination boilers, this expansion vessel is incorporated in the boiler. We will recommend, although there's an expansion vessel incorporated in the boiler, to install an additional expansion vessel, because the water expansion is probably more in your domestic system than what they've allowed for in the boiler. Expansion vessels are fairly inexpensive, but we need to be careful about the different types on the market. we're seeing an industry changing now, whereas rubbers that's used in these expansion vessels, some are fairly diffusion proof, such as butyl rubber. That means they allow less air to expel and less air to get into your system. There's no point in removing air with a microbubble air separator if you're going to allow it to get back into the system via an expansion vessel. So it's important that when you are choosing an expansion vessel, you look for one that's with a good butyl bag and not one that's perhaps got a permeable rubber which will allow air to be trapped back in. The calculation of these vessels is not a rocket science. And IMI, as well as our competitors, have a free download. It's an app which is called Hydraulics, which you get from Google app or Apple app is the other one. But anyway, you can download this software. It's actually free to use. You put in your boiler load and it will tell you what size vessel to install. It will also give you a rough idea what to charge that vessel to, because that's important. We know on a combination boiler, if we lose the pressure, we we connect it to the mains water and we pressurise the system back to generally, say, 1 bar. The expansion vessel is equally the same. You've got to charge it so it maintains that 1 bar of pressure. But to size it, it's not rocket science, you can use the tool to do so. So we have expansion, and expansion by taking up the water expansion in the system, and when it contracts, moving it from the vessel back into the system, is important to maintain a good pressure maintenance on your boilers, allowing the boiler to have a good return temperature coming back. You've got microbubble air separators, which is removing air, and you've got a dirt separators to trap the dirt. That improves your water quality, means you have a very efficient system, and you will see savings for that. It's proven in the commercial world. In the commercial world now, you're unable to install items unless they are energy efficient, such as dirt separators and microbubble air separators, and degassers on larger systems. And now we're moving over to the domestic market. It's a good practice to look into the vessels that we're installing.
Could I just pick up on, you mentioned the commercial world, so obviously if people are in the commercial world, they'd probably be used to air separation. I mean, I was fortunate enough to live in America a few years back, and they're called air scoops over there. So this isn't new technology, but for some reason, it hasn't been promoted as much as dirt separators in the UK industry, which is a shame. Going back to the expansion vessels, we have got this very, very, very big boiler market in the UK. I believe half the boilers hung on walls in Europe are happening in the UK. We're putting in more boilers than any other country.
Yes.
There's a few reasons why that is, and I think one of them is they're breaking down quicker. Now, going back to the expansion vessel, we've now had a boiler industry that's kind of hide the boiler away. So a lot of customers, and once again, it always falls down to the engineer. An engineer will go around, they might say to a customer, right, you need an extra expansion vessel, and the first thing they're going to say is, well, where do I put that? I bought a new boiler that goes in a cupboard.
Yes.
So the engineer wants to do really good practice, but are being held back probably by our industry in an own way. But it's, there's a lot of engineers out there that could probably size an expansion vessel, and they want to do that. And like I say, they're being held back a little bit.
Yes.
Is there any way we can get over that problem, do you think?
Not really, but the average domestic 3-bedroom house would probably want no more than a 30-litre expansion vessel, in addition to a combi boiler. This item will be no more than about 350 mil diameter with a depth of 200 mil. It will go into a return pipe. A return pipe could be anything going back towards the boiler, as long as it's close to the boiler on the return. Not exactly. It could actually be fitted within a wall unit of a kitchen unit, even below a kitchen unit where the sink goes, and it could be hidden away. As long as it's accessible so you can test the pressure in the vessel, it's not something that needs to be unsightly, but it's an additional cost, and it's a cost which is not seen by the client, because they would say, well, why do I really need that? If, for example, it's a component element. Customers don't care about component elements. They care about a boiler, and if a boiler has got an expansion vessel in it, so be it. If we now need an additional component, it will be why? Well, you don't, but as we move towards legislation, I think once we get this Brexit lark out of the way and we're back to really looking at what we need to do in the industry to reduce our carbon emissions, we will then see this becoming as a standard. So gas-safe engineers must install an expansion vessel, and it must be checked and maintained periodically. That is in the commercial world, and it is a standard they've got to comply with. Otherwise, they could lose their heating systems by it being shut down.
It's a good thing you picked up on then. So maybe we should get this into some standards somehow.
Absolutely. I think that's the only way forward, because it's, an engineer will go and price something. You will price it as good practice to reduce carbon emissions. The client doesn't look at the longer term savings, they'll look at that initial capital cost. So if it's built into the spec, as a gas safe engineer, good practice, you should be doing this, the cost will come down and customers will be appreciative of it.
So I'd like to come back to John. So the thermal imaging, as I said previously, I think that's something that may help change the psyche of customers. Because once you say, we've got to get back to this idea of the customer needs to expect that the engineer is going to come around and do a survey. And it's going to be quite a complex process. They're going to do heat loss calculations. Heat loss calculations used to happen when I first started, and they kind of don't now. And there's obviously, we all know Rob Berridge, who set up heatengineer.com, if you don't know about it, and that's got very, very good software for doing your heat loss calculations, which is fundamental to our industry. But once again, if you're going to spend half a day going around thermal imaging your radiators, doing a heat loss calculation, doing a survey on whether you need extra expansion vessels, a lot of the time the customers aren't going to want to cover that cost, which means the engineer that wants to do really good practice is then thinking, damn, I've lost out again and I'm going to have to drive or drop my prices. Whereas I think the thermal imaging, once customers get used to seeing this type of survey laid out in front of them, where they get these images, and then I think it will twig that, okay, we might have to pay a little bit more for a good engineer to come around and do what they really want to do. Because engineers, by their very nature, want to do some good stuff. But for some reason, our industry, the price point's been driven down so low, people are having to...
It's interesting, being a German manufacturer, we obviously, see a lot that's happening across Europe with regards to both domestic and commercial installation. And when the Germans sort of look at what we're doing in the UK, they're often horrified by it. It almost seems to be a race to the bottom. And it's not about who can install the cheapest boiler with the cheapest quote. It should be about putting the system in that's then going to last properly. It's going to be the most energy efficient for the user. And there is a different, I think, mindset if you look at the way the Germans approach the market, whether it's a domestic install or a commercial install. And I think we've got to do something in the UK. Well,
I think the European industry has supported their engineers. I get the feeling that we've been, for the last, I come from the boiler industry way back when it sort of was first engendered from the oil side of it. But I think this has been this big drive with the boiler industry. We forgot actually that a boiler is just part of a system. There's a big system. And I believe in Germany, if an engineer rings you up and says, I want to come around and service your boiler tomorrow, by law, they have to allow that engineer, have someone there on the premises to let that engineer in. Can you imagine if an engineer did that in this country? So I think our industry has a very, very big, it's a challenge, but they've got to really start supporting the engineers and plumbers out there. Because they really want to do some good work, and they're obviously now interacting with the new technology. I take engineers and we take them up to Imi and we show them the different pieces of technology, and they really want to use it.
Yeah, definitely.
But we do need our industry, I think, to start supporting the people that are very important, which is your plumbers and your engineers. Rob, how do people go about getting your thermostatic radiator valve?
What, purchasing? So purchase direct from ourselves. If you come and see us, we're on one of the stands sort of just the other side of the steps. Purchase direct from ourselves. We'll give you a catalogue, chat to one of our reps. Alternatively, we've got a few online retailers stocking our products. There's an online retailer sat with us on the stand today who's doing sort of same day, next day delivery, order it online type scenarios. Or if you're working specifically with it, if there is a merchant, an independent merchant that you say, well, I'm always visiting this merchant, I want to buy everything from them, we can talk to those guys as well. We're quite flexible in terms of purchases in our product, so we can kind of go wherever you want to get it, whichever's easiest for you, if that's direct through a website, or if you want to go and visit a merchant and you buy everything from there, we can look at talking with a merchant for you.
You also do training days, I know, at your facilities, don't you? And you do a commercial training day, and I believe you do a domestic training day.
Yes, so it's we do a light commercial day and a domestic day. So the light commercial day is aimed for the sort of the engineers that have been doing a bit of commercial work, things like care homes, schools, but needs sort of that next level of knowledge in terms of how to balance and set up a system, and how if you don't balance, how it can affect it and that sort of thing. and then we do a domestic day, which is a little bit more on the actual products themselves, the TRVs, how you balance with our products, why you should balance, what happens if you don't, and also ways of making sure you optimise the system, because the whole sort of ethos of our company is system optimisation. So looking at savings through making an existing system work better, rather than looking at throwing thousands of pounds at a brand new system to try and gain some efficiencies, when in reality a lot of the time you can do it relatively cheaply with as long as you're sensible with what parts you're upgrading, which bits you're changing. We can look at it that way and how we can optimise systems that way.
John, does Testo offer any training, or would someone need training to use your thermal imaging equipment?
We've made the cameras now so easy that if you go back to probably 8 or 9 years ago, even a basic thermal imaging camera, you needed a certain level of understanding how to initially set it up and get the best results. Now the tradesperson's cameras, we have at this sort of level, it really is a take it out of the box, power it up, and you're good to go. They're very, very simple to use. Things like auto scaling ensures you always tend to get the best images. Half the battle with thermal imaging is not actually understanding how to use the camera, it's trying to interpret what the image is telling you, and that just comes through experience. But the cameras themselves now are probably one of the simplest you'll ever pick up and use. And
it looks pretty rugged, it looks pretty robust,
Yep.
which is obviously advantageous for someone that's chucking tools or whatever in the back of their van.
It's designed as a toolbox tool. It comes in its own carry case, but they are ruggedised. It's designed to be out there and being used on a regular basis.
And does it interact or communicate with people's phones or pads, or how would they?
Yeah, there's different versions. The basic version literally will just give you a thermal image straight on the camera. If you want to pay a little bit more, if you've got the budget to pay a little bit more, the next level, we have cameras that connect via Wi-Fi to a smartphone or a tablet. That really enables you to send the images direct while you're on site to your smartphone, do a report within the smartphone. There's a little app that we do as a free app, and then you can send that as a report with your customer logo and all your company details, so it looks professional, very, very quickly, straight from site. And we've got 4 cameras in the range. We've got cameras at the budget to suit as they go.
So would that one take an SDS card? Have I got that right?
All the cameras have a built-in memory, so you don't need SD card or anything like that.
Right.
And typically you're going to get about 300 images.
So stored. I could still download that to a computer?
Correct. Even the basic version, you still got the option of using free software that is bundled with the camera. You just plug the camera in via a USB lead and download the images.
I mean, you mentioned the word there, professional, and I think this is something I speak to a lot of engineers, and they love the idea that one day they actually might get valued as being a professional again, and being able to do these surveys, these reports, to preempt maybe an install, is something that's, I think, going to help them look very professional in front of the customer. And hopefully, our customers will start to value us again in our industry, because we're so important. I think the World Health Organization state that a plumber is the most important trade on the planet, even more frontline than doctors. Because as my lecturer used to say, we prevent more death and disease than doctors can cure. Sanitation is vital for humanity. And then obviously the heating engineers that we got are out there are going to become more to the focus as we go into this big low carbon agenda that obviously everyone's discussing. And I think today there was a big announcement by the government. I think we're the first country to actually put it into legislation that we're going to go zero carbon by 2050. So our heating engineers are vital. And so one of the reasons I want to do my podcast is to sort of get around and meet all these engineers, listen to their stories, how they got into the industry. They might be quite new to the industry, but are soaking up all this knowledge. I've met a lot of new engineers that have been down to the IMI factory, are learning about de-aeration devices, are learning about hydronic balancing. And it's actually looking I'm quite optimistic that the future's looking quite bright for the engineer. Like I say, if we can get the industry supporting the engineers again, and we change this perception by customers that they start to I think the rogue trader programs that come out about 20 years ago kind of destroyed our industry a little bit. They all think we're out there trying to exploit customers. And that's not the case. That's a very, very small, thin slice. Generally, an engineer just wants to do a really, really good job. So thank you very much. I'd like to thank you all in the audience for coming to the first seminar of the day at PHEX. Hope you enjoy the rest of your day at PHEX and maybe have a little visit to the stadium. We've been out there and had a little look, haven't we?
Yeah, a little look this morning, yeah.
Thank you very much, and thank you to my guests, John from Testo, Rob from Imi Hydraulics, and
guys.
Derek from Imi Hydraulics. Thank you very much.